Why we need to take that one? We can take we can take id1 equals to id2 plus temp1. Already we have multiplied this one. Now up to here we are storing one variable, that is, I will tell you. Here we are having plus operation, right? id2. Now id3 and 60. Why now up to here we are storing this into temp1. Why we need to waste another variable to store this entire value and again assign to the id1? We can take directly id2 plus temp1 is assigned to id1. Like that we can optimize, right? So now here we have removed temp1 variable and temp3 variable, and only we are taking only one variable, that is temp2. Here we have changed to temp1, right? So like this we need to optimize the code. We have written from each statement here, for each statement. Now we can optimize the code. Now this is a code optimizer. Now final stage, that is final code generator. We need to generate the assembly language from the code optimizer. So this will be the input to the final code generator. Here you can see that first what we need to do, first we will store, no, we don't need to store the constant value. First we will store the id3 value into one register. In assembly language we will use the registers to store the variables. So move means we are moving the id3 value to register, right? And here you are using f. The f means float value. We are using the float value, right? We have considered that this id2, id1, these all are the float values, so that's why we are including f here. So move f, we are moving id3 to r2. So we are storing this value into this register, okay? And the next one is we need to multiply it by 60. So what is the function? Mul, mul. F, because we are multiplying the float numbers. Here we are giving 60 here we are giving 60 for, here you can see that there is multiplication operator. I mean here we can see that the hash function, the hash symbol. Why? Because for the constant values you need to use hash symbol to define the constant values. Now we are multiplying with the 60 to id3, which is, here we have already converted to id3 is already stored to r2, so now we will give r2, right? So that is the second step. Now up to here we have completed. So the result, we don't need to take another variable. The result automatically stores to the r2 value. Now the r2 is equals to r2 into the 60. The r2 is nothing but id3 here. So the resultant is automatically stored to the r2 register, okay? And now here this one is completed. Now we need to go for this one. What we need to do? We need to add first we need to take first id2 to one register. Take, here you can see id2 is storing into one register, which is r1, okay? And this r1 is adding this, already we have this temp1 is now is r2, right? Because we are storing this entire value into temp1 in the previous one. Now this entire thing is already stored into r2, so we need to add id2 plus r2, right? So first we have stored this id2 into r1. we have stored this id2 value into register 1, and this register 1 value and register 2 value should be added. So we need to use add function here, add f float value we are adding, so r to r1. Okay, and the last one is we need to assign now the result in which the result will be stored, because we are already told, I told that the second one, with the second operator, the second register will store the result. Now this means r1 equals to r1 plus r2, so the result is now stored in r1. Okay, so this r1 should be assigned to the id1 variable. So now we just give move f r1 to id1. We are just moving this register the result to the id1, right? So this is the entire process of converting from one single statement source program to the assembly language. I hope you understand, right? And we are having one more topic, that is the cousins of compiler. We can also say that cousins of compiler. Okay, so the now before we are giving the source program to the compiler, first it will go to the preprocessor. So you can see that the source program will be go to the preprocessor. So in the preprocessor it will be add the hash include, hash define, any directives are there means it will be added in the first step, that is in the preprocessor step. So the next one, it will be added and it will be go to the compiler. Now we have seen the different phases of compiler. What is the output of the compiler? The assembly language of the input one. So now it will be go to the, I already told you, we only convert the input to the assembly language only. Assembly language only. We didn't convert that assembly language to the zeros and ones, which is understand by the machine. So this will be done by the assembler. So the assembler will take the input assembly language and it will convert the this one into zeros and ones, and this zeros one means is nothing but the relocatable machine code, and it will be go to the loader and the linker, which is the linker will link all the files which are related to this file and convert it into single file. Okay, and this single file will be taken by the loader and it will store in the memory. Okay, so it will, you can see that the libraries and relocatable object files, it will take the linker will take all these files and it can convert to the executable one single file, and that will be taken by the loader and it will store into the memory. So this is the entire process. So now it is a compiler is a part of this language processing system. So I already told you that in the preprocessor we will add the input to the compiler, provide the input to the compilers, the macro preprocessing like hash define, x is 3, a, like that we will define here, and we will include the hash include files. So the next step is assembler. I already told you it will take the assembly language and it will convert the relocatable bit code. Okay, and now the next stage is compiler. The compiler will give the assembly language. I already told you that, that's why we are not discussing here. And now after the machine code is generated, that will be stored to the go to the linker and link editors. So you can see the link editors taking many machine code programs and produce a single file. So it will take the input from the assembler and it will take the relatable files, any files are there for that one. It will take all the relocatable machine code programs with the cross references, and it produce one single file, executable file it will generate. That executable file will be taken to the loader, and this loader take the relocatable machine code and altering the addresses and placing the alternate instructions into the memory. Okay, so the last one is grouping of the phases. Now we have seen the 6 phases of the compiler. So the 6 phases are the analysis phase. In the analysis phase we are having syntax analysis. The first one is lexical analysis, Second one is syntax analysis. Third